So in the final day of our study of relativity, we are going to be looking at black holes. And this is probably going to be a 7-part series dealing with black holes. At first, we need to define a black hole. So what exactly is it? Well, the concept actually started back in Newton's day. Newton predicted what we call terminal velocity. So he recognized that planets had a certain pull of gravity, and that if you weren't fast enough, you would not be able to escape that pull of gravity and you'd have to come crashing back down to the planet. Or, at best, maybe get trapped in an orbit around the planet. So you neither crash nor escape. Well, he did wonder, pure speculation, was it possible to create something that was so massive and had such a strong pull of gravity that nothing would be fast enough to escape? Now, he wasn't thinking that the universe would have a limit in terms of light speed. He was just centuries before things like rockets, so he assumed that there was going to be some launch from the ground to get you there, and he thought that that technology may be limited. Well, it wasn't long after Einstein published the theory of relativity that even the special theory, when people realized, hey, if c is the upper limit for the speed of light and nothing in existence can travel faster than the speed of light in a vacuum, well then we have a limit on the terminal velocity. There will come a certain speed where you are, or a certain mass and a force of gravity, where even light is not fast enough to escape because the terminal velocity was greater than the speed of light. The fact that the special theory of relativity was dependent on the fact that you weren't in a strong gravitational field did give people hope that there would be some way to resolve it or to eliminate it. But eventually we learned that no, there really is this thing called a black hole. It was theoretically proposed, and now we've got some very strong candidates. We've even managed to take images of these things that cannot be seen. But a black hole is really just something where gravity is so intense that the terminal velocity, so the minimum speed you need to obtain to escape, is greater than the speed of light. On one hand, that sounds pretty simple. Something gets so massive, light gets pulled in. Now that we know light is warped by gravity, as we learned in day 4, it could be twisted and varied around. So if light cannot escape, there'd be a spot in space that just looks black. The original ideas proposing how to find them would be look for areas in space where stars just disappear for no reason and then reappear. The idea being that a black hole would have gone in front of them, swallowed the light from that star, and then as it passed by, allowed the light to get through again. So that is a method that has been attempted. It hasn't been as effective as other methods. But this is the basic idea of the black hole. Gravity is so powerful at the surface, nothing can escape, or near the surface. Now, I do want to clear up a misconception. People have the idea that if, say, the sun suddenly became a black hole, that it would suck in the entire solar system and destroy us all. Well, that isn't what happened. At the distance we're at, all our planet cares about is that total mass. So if we were to actually take the sun and turn it into a black hole that had identical mass to our sun, Earth's orbit wouldn't change. We'd keep orbiting just as we always had. Now, the lack of light and heat would be an extremely serious problem, and whatever it is that turned the sun into a black hole would probably have some pretty devastating side effects throughout the solar system. But the gravity itself around a black hole behaves normally for the most part. As you get close enough, it does start to do very, very weird things. But you have to be closer to that black hole than the current radius of the sun before you really start to notice those effects. So, generally speaking, if you are orbiting a black hole, it's the same as orbiting anything else with that mass. That doesn't make it safe. Anyway, so how big would the sun be if we turn it into a black hole? That is going to be the topic of our next video.